11.2 example 1 gets us to actually do a combination. And I'd like to point out how we know it's a combination and not a permutation. So it says there's 12 females, 18 males in a grade 12 class. Then it says the principal wishes to meet with a group of 5 students to discuss graduation. There's no mention of, if the first person chosen is the spokesperson or, the president, vice president, treasurer, whatever that is. The students are either talking to the principal or they're not. And that's what makes it a combination, because you are either in the group of 5 students or you're in the group of 25 students that haven't been selected. That's it. It doesn't matter if you're chosen first or second or third, makes no difference. So I'm just going to kind of remind myself. I always forget the numbers on these questions. So there's 12 females, 18 males. Worth mentioning that means that there's 30 students, right? Just 12 plus 13. And that's really how we're going to do part A. Part A doesn't have any restriction, it just says how many selections are possible. Well, there's 30 students, so I'm going to take the 30 and we're going to choose 5 from that 30. Now I'm going to put this into the factorial and then we'll use the button on the calculator. 30 choose 5 can be written as 30 factorial over 30 minus 5 factorial times 5 factorial. Worth seeing at least again how to manipulate these factorials. So this is going to be 30 factorial over, 30 minus 5 is 25. And then I'll keep the factorial there times 5 factorial. The way that you can simplify this is by rewriting 30 factorial to contain 25 factorial in order to make some cancellations. 30 factorial is 30 times 29 times 28 times 27 times 26. And then I'm going to stop there and put the factorial on the 25 instead of writing 25 through 1. And then all of this is divided by 25 factorial times 5 factorial. The 25 factorials would cancel, and I'm left with 30 times 29 times 28 times 27 times 26. And then 5 factorial works out to 120. And you could certainly type that into your calculator, but definitely we want to get used to where the button is because we have, and most, if not all, scientific calculators will have combinations somewhere on there. In order to access that on the calculator, it's actually in the same spot as the permutation. So similar to permutations, you actually have to type the n in first. So I'm going to type in 30, go to math, over to probability, and then we see the correct notation, NCR. So 30 NCR, and then we're going to choose 5. And I'd like to show you that if I did 30 times 29 times 28 times, we'll get there, 27 times 26, and then divided that by 120, I would get that same answer, right? And it should be noted that if I did the actual factorials, so 30 factorial divided by 25 factorial, and then because the 5 factorial is in the denominator, it is also dividing the numerator. And so I'll just put that in place. And I get that number again, right? A few different ways to show that. So 142,506. So 142,506. And I'm just going to put selections. Now that is a lot of different possibilities, and that's if the order doesn't matter. I would encourage you, if you have your calculator handy, check what 30 pick 5 is. And it's actually that number multiplied by 120. So a very, very big number of selections are possible here. All right, part B, and this is similar to when we did permutations. We start to introduce these, restrictions. It says how many selections are possible if the group consists of 2 females and 3 males. I'm just gonna write that here. So 2 females and 3 males. Now, we are making both of these selections. So we're gonna multiply the number of possible 2 female selections by the number of possible 3 male selections. But it's important that we don't have 30 females and 30 males to choose from. So what I'm gonna do is I'm just gonna split this into the 2 female, and I'm going to put that multiplication symbol by the number of 3 male selections. We have 12 females, so 12 choose 2 gives me the number of different unique 2 female selections. And then for the males, it will be 18 choose 3. I'm going to use my calculator for those within, and then we'll do the multiplication kind of after the fact just to make sure we see it. Please do ensure that you can use your calculator to find this. 12 choose 2 is 66. And then 18 choose 3 is 816. Now, I really want to point this out. The reason we're multiplying is for each one of those 816 different male kind of members, there is 66 different female combinations that can be combined with it. That's why we multiply, is because we're selecting 2 females and 3 males for that group of 5 people. And if I take 66 and multiply it by 816, I get that there is 53,000 856 different selections that have two females and 3 males on them. All right. C asks us, one of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female, and 3 males are possible? We are going to do something very similar here. So I'm just going to put that we have to have Brooklyn. I'll write out Brooklyn. Then we're going to multiply by 1 female, the number of different 1 female groups. And then we're going to multiply by the remaining members, which would be 3 males. Now, if we have Brooklyn on our selection, it is 1 choose 1. Right? Only Brooklyn can be there. So we're selecting Brooklyn from us, assuming there's only 1 Brooklyn in this class. For 1 female, don't get carried away here, because you have to remember that once we've selected Brooklyn, she can no longer be selected. So there are no longer 12 females to choose from. There are 11 females to choose from, and we're choosing 1 of them. And then I'm going to multiply it by 3 males. I'll write out what the combination is. For 3 males, it would be, again, 18 choose 3. 1 choose 1 is 1. 11 choose 1 is 11. There's basically just 11 different people that can be selected. And then from above, 18 choose 3 was 816. When I multiply those by each other, so 1 times 11 times 816, I get that there is 8,976 different selections. Now, I think it should be noted that the more restrictions we put on a question, the less possibilities there are. And that's something that I is really important, I think, intuitively when we talk about this, chunk of the course, that, as we're talking about the number of different arrangements, the way that we can extend this to maybe a useful, I don't want to say useful, but a useful use of this is the idea, what if we wanted to know the chances of Brooklyn being on the committee? Well, we could take the number of selections that involve Brooklyn, and 1 female and 3 males, and divide it by the total number of selections, and that would give us the chances that Brooklyn is on that committee. And looking at this chapter as probability theory and game theory, I think gives it a little more of a use, because I think most people like card games or board games or games of chance, and this is really the math behind those games.